Hi, in this video, this bonus video, we are going to have a look at what looks to be a complicated definite integral, but it's actually not that bad at all. And I'm also going to show you very quickly how you can use a little extra feature of the chain rule in order to make this problem even simpler still. I went through this on class on Friday with a different example, so this is just a follow-up to that. So it looks awful, doesn't it? It's the definite integral from the lower bound of 3 over root 2 to the upper bound of root 14, 4x times 2x squared minus 1 to the power of negative 2/3 all over 3. That's a pretty tricky problem, but it's not. And it's not even a calculator problem, believe it or not. We can do this without a calculator, no problems at all. The first thing to observe, if you can, and it's okay if you can't, that if we have a look at the inside function here, which is 2x squared minus 1, I can see that the derivative of 2x squared is 4x, which is good because that's what's out here. So by inspection, it looks like that we're good to go with using the chain rule, or the onion rule as I like to call it. So we do our usual setup. I might just go to black so it stands out from the problem. So I'll go let u equal 2x squared minus 1. Therefore, du is equal to 4x, that's just the derivative of 2x squared, and minus 1 goes to 0, so that's not there. So it's 4x dx. And there's the 4x there, so that's good to know. But this next thing is something that I haven't shown you formally in any other video, and that is what I can do with a definite integral is I can now substitute in the boundaries for x here to work out what the new boundaries are for u. And if I do that, I no longer have to return back to the x values at the end. I'll show you as we go along. But I'll just do that quickly now. So at x equals 3 on root 2, u is equal to 2 multiplied by 3 on root 2 squared minus 1, which is equal to, well, 3 on root 2 is going to be 3 squared over root 2 squared. So root 2 squared is 2, so it's actually going to be just 9 over 2. So that's equal to 2 multiplied by 9 over 2 minus 1. And that's going to equal, well, the 2's will cancel out, leaving me with just 9, and 9 minus 1 is equal to 8. So I now got a new lower boundary of 8. And the upper boundary at x equals root 14, u is equal to, this is a little bit easier, 2 multiplied by root 14, all squared, minus 1. And we know that root 14, when we square it, it'll just be 14. So it'll be 2 times 14 minus 1. 2 times 14 is 28, minus 1 is 27. I wonder if you can see something special about these numbers here. All right, I'll zoom out so you can see the whole 4 slides at once. What do we do then? That means that the integral is now the integral between 8 and 27, nice simple whole numbers, of, let me see now, we've got rid of the 4x and the dx there is now going to be just du. So those two get replaced by du. See the 4x dx? Du. So the 4x dx is replaced by du. The 3 is still there. So it's a fraction. So rather than just putting the whole thing as a fraction, I'm just going to put it as a constant fraction at the front. So I'm going to go 1/3 u, which is what 2x squared minus 1 is, to the power of negative 2/3 du. So I've wiped out all presence of x completely. These new boundaries represent the boundaries if we were looking at the graph of u. Okay, so that's the integral. Oh, sorry, I don't need to do that anymore. So that means I've got, let me see now. If I have u to the power of negative 2/3, then I would add 1 to that, and that would give me positive 1/3 here. And so my integrand will be worked out by flipping 1/3 to get 3. So I'm going to end up with something like this: 1/3 multiplied by 3 over 1, or just 3, u to the power of 1/3, and that's between 27 and 8. Now, u to the power of a third is just cube root u. So the third and the 3 will cancel each other out. So I'm left with the cube root of u between 27 and 8. What does that equal? Well, that would be the cube root of 27 minus the cube root of 8. And that is equal to 3 cubed is 27, so 3, and 2 cubed is 8, so that's just 2. So the whole kit and caboodle is equal to 1. And that's all you need to do. Well, I say all. So there's a few tricks there, I suppose, but I guess the critical thing I wanted to point out is that not only can you use the onion rule or chain rule to make your function simpler here, but you can also change the boundaries by putting a bit of work in here as well. And by changing the boundaries, note that I never, ever, ever return to substituting x in because I don't need to. If you don't do this work at the start, you'd be better off writing this, I think. And I don't know, this is my notation more than anyone else, but the integral from x equals root 14 to x equals root, was it 3 on root 2 of u, a third u to the negative 2/3 du. I think you'd have to do that really because otherwise, because these boundaries don't relate to u at all. So you'd probably have to do something like that, I think, to be fair. Okay, I hope all of that makes sense. Please feel free to ask questions if you're not too sure.